Welcome to FHIR Profiling and Implementation Guides. Over the next few minutes, we will cover these two very important topics, which are really helpful in understanding how to use FHIR in real-world applications. My name is Patrick Jameson. I'm the Product Manager for Iris for Health, and I work closely with our FHIR core stack and interoperability. FHIR was designed as an interchange standard. However, there is no data model in healthcare that encompasses all use cases. Therefore, the base FHIR resources were designed to cover 80% of the common data elements in healthcare, and extensions, which are added patients, can be designed to cover the remaining 20%. There are many different use cases in FHIR. A FHIR implementation guide specifies which resources are needed to support the use case under consideration and defines rules and requirements or constraints based on that use case. This process is referred to as FHIR profiling. FHIR profiles allow you to customize resource definitions by constraining which elements of a resource are required and which are not. As such, profiling is an essential part of FHIR adoption. Profiling also helps provide the missing extensions that should be added, and which FHIR API functions and terminologies should be used. Terminologies in FHIR are defined using value sets and code systems. The constraints and extensions of a FHIR resource also help improve the quality of data by encouraging data consistency and manageability. The base FHIR spec is a reference implementation which is very generic. Implementation guides are a set of constraints and supplement the base version for a specific use case. And profiles are the specific resources that are used generally in implementation guide that can be extended with extensions, but also have a number of constraints. The FHIR standard introduces what's called a conformance package. A conformance package typically contains a set of related resource profile definitions, a manifest listing all the available profile definitions based on the composition resource, and an implementation guide describing the profiles. A typical FHIR profile can consist of general requirements describing the goal, category, and the original resource configured by the profile, a section with a full configuration of the profiled resource, and a differential section focused on the differences between the profile and the base resource. This section and the profiler tool help make profile configuration easier for data analysts. And if you attend my next talk on FHIR shorthand, we'll show how to actually create an implementation guide and see these sections. FHIR profiles are expressed using a particular set of resources called conformance resources, which are embodied in structure definitions. Structure definitions define the elements, data types, and extensions. Profiles modify base FHIR resources. Now here are some key aspects of FHIR structure definitions. First, there are element definitions. These specify the elements or the fields that are allowed with a particular FHIR resource. Each element is described in terms of its name, data type, and cardinality, which means how many times it can appear, and other properties. You have data types. Structure definitions define the data types that can be used with a resource's elements. FHIR provides a range of data types such as strings, dates, numbers, and more. And structure definitions specify which data types are appropriate for each element. We also have value sets. Structure definitions can reference value sets, which are used to define the allowed values for coded elements. This helps ensure that the data being exchanged conforms to standardized terminology and code systems. We have constraints. Structured definitions can impose constraints on how a resource is used. For example, they could specify that certain elements must be present or that certain values must be used. And then finally, we have extensions. FHIR allows for the creation of extensions to add custom data elements to resources. Structured definitions define these extensions, including their data types and constraints. Structured definitions are crucial for ensuring interoperability in healthcare information exchange. They provide a standardized way to describe the structure and content of healthcare data, allowing systems and applications to understand and exchange information consistently. FHIR structured definitions are typically expressed in machine-readable format, typically XML or JSON, and are used to validate FHIR resources exchanged between different healthcare systems, ensuring that the data conforms in a common standard. Now, creating a profile is just a series of simple steps that we will see in just a few minutes, but it starts with a base FHIR resource, for example, the patient or the observation resource, laying on some constraints, usually in the form of rules, and then finally adding an extension to that resource. Here are the simple steps for profiling a FHIR element. Before we get into this in too much detail, I'd like to talk about something that is often confusing, and that is this concept of must support. Must support means that when an element within a FHIR resource is marked in this way, that every system or application that claims conformance with the FHIR standard must implement and support this element. Failure to support a must-supported element would be considered not compliant with an implementation guide or a FHIR specification. The must-support designation is essential for achieving interoperability between different healthcare systems and applications. It ensures that critical data elements required for meaningful data exchange and processing are consistently available. By defining which elements must be supported, the FHIR structure definitions help establish a common baseline for data exchange. This consistency is very important in healthcare, where the accurate and complete representation of patient data is crucial for providing safe and effective care. So, in profiled resources, must-support requirements are often defined within the profile. A profile is the set of specific constraints and extensions applied to a FHIR resource, tailoring it for a specific use case. So we start with a specific FHIR path, for example, patient/identifier, and now we must designate whether it must be supported or not. And then we'll lay on constraints such as cardinality, or binding to a specific terminology, or constraining it to a specific type reference to a given FHIR resource. The red squares that you see on the right side, marked with an S, indicate that these elements in this FHIR profile must be supported. And that's why we often have a differential profile between a snapshot, which identifies all the elements, and those that are must supported in FHIR, where you see in the differential. Let's talk a little bit about cardinality. This is the number of times an element is used in a resource. We have a lower bound for the cardinality and an upper bound. So 1 ... means that we must have at least one of these elements, but could have many more. When creating a profile, we cannot express a constraint that is inconsistent with the base FHIR standard. So we're not allowed in, for example, to say 0.1 if you must have, for example, at least one element. We could also express the strength of a binding of a given element to a terminology. And in this example here, you see that strength is extensible. So let's see what this means in terms of fire profiling. We have a number of different ways in which we can specify the strength of a binding. Required means that if this terminology is valid in the fire spec, that element has to have an element from the required code set. Extensible means that we should choose a code from the value set when it is available. But if it's not available, we're allowed to extend it, extensible, so we could create alternate codings. Preferred is a looser standard. That just means that we're encouraged to draw from the specified codes, but we're not really required to do so to have a valid fire element. And examples are even the least bound. You're not even expected or encouraged to draw from the value set. It just merely provides an example. I'm not going to cover operation definitions in detail. There are other conformance resources in a fire implementation guide, including these operation definitions. An example of this is $validate, which ensures conformance with a particular profile, or $everything that can return all the resources in a particular fire compartment. We could also, in FHIR, define our own search parameters, which is also a conformance resource. Here's a partial listing for some of the elements in the search parameter resource. So to summarize, fire in the real world is based on a base fire specification, which is a platform spec that's completely general. But real use cases, such as the DaVinci Prior Auth implementation guide, specify specific standards that are often generated by vendor consortiums or national standards to implement FHIR in a very specific way. These implementation guides are frequently contained in registries so that you could easily access these guides over the internet. Profiles are part of an implementation guide. The implementation guide is a set of rules about these FHIR resources. It is a FHIR resource itself, but it has both content, which are these conformance resources that are computable, and documentation that is published on the web through the use of the FHIR Implementation Guide publisher. Here's kind of a diagram that shows you all the linkages between an implementation guide and different elements of that guide. So you could see you have operation definitions, search parameters, compartment definitions. But the most important thing is the structure definition. And that's how you conform the different FHIR resources to this implementation guide, by doing that kind of profiling. FHIR profiling and implementation guides are not only for HL7 committees. They are key to making sure that FHIR is an interoperable standard for the use case that you are implementing it for.